Let's take a look at the database that we're going to use for our examples in this class. It's called the SNDB database. This is a sample database that was designed expressly for teaching database concepts. The data were derived from a real clinical database, but then tweaked and adapted over time, specifically so that we can learn certain aspects of SQL. So what we have is a pretty small database of clinical information that's been intentionally designed for certain aspects of practice. And you'll see as we get into design next week or so that some aspects of this database might not precisely match the optimal design principles that you're going to learn. So these are the tables in our database. There's one that is called DEMOG that has basic information, demographics about the patient, name, and so forth. There's admitting diagnosis and discharge diagnosis. These are called ADM underscore DX and DSC underscore DX, admitting and discharge. There's a vitals table. Vital signs are those measurements like temperature, heart rate, blood pressure. There's a blood table that has a few selected lab tests, and a meds table that lists medications. When you look at table descriptions, both in the literature and in my own notes, you'll often see this kind of notation that has the table name first, and then in parentheses, the names of all the columns, and the primary key, at least when I do this, will be underlined. So you'll recall from week 1, the primary key is the column or set of columns that identify each individual row in the table. So you can think about the idea that patient ID is sort of your identifier for one patient. That is part of the primary key, but not the entire primary key, in other tables in the SNDB. Now, most often the patient ID plus something like a date time column is what constitutes the primary key in the other tables. So this is a graphical view of the columns and tables in the SNDB database with the column or multiple columns that make up the primary key underlined in this graphical picture. Now each column in any database has a predefined data type. Common data types are those numeric data types, and often specified as being an integer, a whole number, or something like a double or single. Those imply that there can be decimal point values. Date time is kind of an interesting data type because it's almost always stored together in a single column. And the way that it's stored doesn't always look like a date time. It sometimes looks like a number with a decimal point value, where through some sort of magic manipulations, the whole number part represents like the actual date and the decimal part represents the time, or there's different ways they go about storing it. But for our purposes, the thing to remember is that dates and times are usually combined into a single column. There's columns that contain any sort of free text, alphabetic letters, symbols, and so forth. And these are variously named from one system to the next. It might be called car, string, varchar, text, or there's other names for that data type. And then some databases include other data types like binary values, for images or so forth. Now, an important thing that differentiates a database from like a spreadsheet is that those data types for each column are generally pretty strongly enforced. So if it's defined as a number column, you often cannot put letters in that column. So finding out what's in your database, a little trick you can use with SQLite, the database we're going to use in this class. You can go in your terminal window and open SQLite database and type in these dot commands that are shortcuts to certain standard SQL queries. So in SQLite you can type dot tables and it'll return a list of all the tables that are in that database. And similarly in the terminal window you can type in dot schema and it'll give you back not only the name of the table but a description with the data types and the columns and so forth. This isn't totally unique to SQLite. So like in Oracle, for example, I can go in once I get the list of tables. So there's a system table called user tables that I can get a list of the tables from. And then I can use a command that's DESC to have Oracle give me back the table description, the columns and data types and so forth. So this is a common shortcut in many DBMS. The words you use or the approach you use to get it might vary, but the idea that you can give a command and find out the metadata, the table structures, is pretty common. Now you recall the idea that in a relational database there are tables that represent topics and there are links between rows of data and how these rows could potentially link up. These are called relationship types. So you might have a one-to-one relationship. That means one row of data in the first table can only ever match up with one row of data in the second table. So their number of rows, you can only match one row. A really common relationship type is one-to-many, where you have one row of data in one table, like our demographics table, and that person might have multiple rows of data in another table, like our discharge diagnosis. Now, many-to-many relationships are actually conceptually possible in a relational database, but when it's implemented implemented as two one-to-many relationships, and there we create sort of a join table in between the two parts of the many-to-many relationship. So the video in your module where he said many-to-manys can't exist in a relational system, that's sort of true, sort of not true, because there's a way to make it work. Now, you'll often see in graphical designs, entity relationship diagrams, which you'll learn about next week. This idea of many is variously represented, oftentimes as an M, sometimes an N, sometimes the infinity symbol is also used to, those all mean many, and there's really no difference between when you would use one versus the other. Okay, the rest of this PowerPoint you're going to want to download and look at. I'm not going to walk through in detail because what it contains is the detailed descriptions of each table, the column names, the data types, how big the columns are, and so forth. And this is just for reference for you as you get ready to write your queries. So download this and you'll have it available to you when you need it.